Right, so a cookie company is trying to maximize profits by examining how changing the price of the cookies will impact sales. So they determined that S equals negative 2p squared plus 14p minus 2.5 is that equation where S is the sales in millions of dollars and p is that price of the box of cookies. And anyone know what maximizes sales? That word maximizes should ring a bell because when we're looking at maximization and we have a quadratic, we know that we're looking at trying to find the vertex. And we know it's a maximum because of that negative p squared means that if we graphed it, it would be a downward facing parabola. So our vertex would be our highest point on the parabola. So let's find it first algebraically. So I know that for my x value, I take the opposite of b. So that would be negative 14. I'm going to do 2 times a, which is negative 2. Well, a negative over negative gives us a positive, so we have positive 14 over 4, which is 7 halves. Well, remember, the price is p. And so this is really, should be written as monetary value, $3.50. Now, on top of that, we get to our second part of the equation, which is what's the maximum sales expected. So if we know that the price is $3.50, we can substitute that into our sales to find what we have. So 350 squared plus 14 times 350 minus 2.5. So when I do this, I get negative 2. Remember, it's 350 squared, so that's 12.25. 14 times 350 is 49 minus 2.5. So this becomes negative 2450 plus 49 minus 2.5. And when I add them all together, I get 22. That means the sales at 350 per box is $22 million. Now, I could verify this graphically too, so let's do that. So S equals negative 2p squared plus 14p minus 2.5. Now, I can't see it on my graph, and again, I want to maximize, so I want to find that vertex. And if I click on my vertex here, I get to 3.5, 22. So $3.50 for each box for $22 million in sales.